Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. We do encourage engagement in the chat. This session is recorded and will be available on the Microsoft Reactor YouTube channel in 24 to 48 hours. Useful links will also be shared in the chat. Which brings us to today's session. This session will run approximately 2 hours with questions throughout. Our speakers today are Jim Bennett and Sam Ronsky, who are both regional cloud advocates. I'll now turn it over to them.
Hello, hello. Good morning, good afternoon, good evening. Hello, wherever you are in the world. Welcome to our tea-fueled fun. How are you doing today, Sam?
I am doing well. It's early morning, so got some matcha, and we're gonna do some more tea stuff, some dashboards, I believe. So I'm looking forward to that.
Now I'm being a bit of a traitor, I'm afraid. Once again, this is the morning stream, so I've got coffee rather than tea for my morning stream.
So what we're building will work with coffee. We're just doing tea because you can make all the fun tea puns like Darjeeling and dashboards.
Really work, does it, compared to IoT?
Not quite as nice of a. I don't know the word for it. I've just completely forgot. It's early and my brain isn't quite woken up yet, so hopefully the caffeine helps.
Not quite as punny, maybe.
That's the word.
Yes. Not so many puns. So, should we do a quick recap of what we've done so far? I think we should.
Yeah, so this is our fourth session, so we should probably talk about what we're building and why, and sort of what we're learning and what we're planning to do. Yeah, because we're kind of pivoting now into more cloud and monitoring stuff rather than the IoT stuff with a T, not T. Anyway.
So what we've been building, we've been building this, haven't we? This is kind of the root of all our things. We are trying to build a supply chain management system because Sam loves tea and Sam does not love running out of tea, do you, Sam?
No.
So we want to try and build up a whole supply chain management system. So yeah, we could just build a little device that monitors how much tea Sam's got and goes, you need more tea. But that's not fun. Over-engineering, ridiculous over-the-top solutions are fun. So we're doing it based off an IoT device and then a whole back-end infrastructure that uses that. This is kind of thing you would get in a professional supply chain management system, essentially, in like stock control, things like that. So we have scales. This is the scales here. Connected to a Raspberry Pi, a lot of cables. A lot of cables, and then we put things on the scales and it weighs stuff, and then we're feeding that data up to the cloud, and then we can use that to make decisions on, do we need more tea? So the idea is you'd have a jar here with tea in it, and then as you take the jar, scoop some tea out, put the jar back, and slowly over time the weight of tea goes down, and then we can use that data to make decisions on when should we order tea next, what should we do with it. Like over the last few shows, we kind of looked at this, we've created the device, written some code. It's Python code running on the Raspberry Pi. Do it all through Visual Studio Code. It's got remote SSH extension that you can install. So we're kind of remotely connected to the Pi. So here I am. I'm on my Mac because I work for Microsoft, therefore I'm using a Mac. And I'm remotely connected to a Raspberry Pi running Linux because, Microsoft, any developer, any platform. We're all about all the things here. And so a little bit of Python code that runs. And then, if I put a weight on my scales, goes up because we picked up a weight, and then take the weight off, and then it should go back down again. And then we've got this all feeding up to the cloud. So we've got it feeding into Azure IoT Hub, which is an ingestion service. It's basically it's a full end-to-end IoT service. It can take data in, take data out. You can configure security around IoT devices, and it's designed to scale to kind of billions upon billions of devices. So we set up IoT Hub. We fed data into IoT Hub. And then we took that data and we fed it out into storage. So we connected up a little connector so we could take our data and put it into a container. And here's all our data. From a while ago. Here's lots of data. What did we 7?
March
7th.
7th.
March 7th. Yes, that's today, March the 7th at 18:03. This is UTC. But look, here's data. So, oh, look, here's some data we've got. Here's all the weights we've got. All encoded data. It gets base 64 encoded, and that data contains the weight. Decode that. Woohoo! There's our weight. So that's the data that's going through. It's going to Azure IT Hub, and we're feeding it through to storage. And that's what we covered in the first couple of streams. The last stream, last week, we looked at Azure Data Explorer because we wanted to look at time series data. So we wanted somewhere where we could take in time series of data. So data comes in over time. We get a kind of key pair relationship. Key is the time. Key value relationship. Key is the time. Value is the whatever data we're assigning at that time. We want to feed that into Azure Data Explorer. And we kind of left the end of last session. We spun up Azure Data Explorer and got stuck. So today we can talk through how I managed to work out how to get unstuck. And then this is kind of where my area of expertise ends. Kind of, I'm the IoT person. This is where my area kind of ends. And this is where Sam's area of expertise kicks in with how we can do other bits and pieces with this kind of stuff. And what are we doing today? It's dashboards, yes?
Yes, dashboards. So we're going to try to get a dashboard that runs live on a Raspberry Pi and pulls data from Azure and then displays it. So you can actually create a dashboard that shows you whatever you want. Maybe set up alerts. If we have time to get to that, that'll be cool. And do a few other things to kind of get everything set up. It'll also be a fun way to kind of explore some open source tools for tracking data. We're going to be looking at containers and Grafana, I think, running Grafana inside of a container on top of our Raspberry Pi. So we can just deploy it, manage its configuration, and keep it up that way. Nice. So I think it should be pretty cool. But also with this series, we haven't done this before. That's an important thing to talk about. So Jim mentioned getting stuck. That's because we're learning how to do this as we walk through it. It's sort of a learning process, and so we'll get to kind of explore some Grafana stuff. I haven't played too much with the newest versions of Grafana, so this will be a little bit of a learning experience for me. The UI has changed, so some fun things, and I haven't connected it to Azure before. I've mostly used it for like Prometheus, so we'll get to see how that all works as well. So it should be really fun. We should get a really pretty looking charts, hopefully. So
yeah, I'm very excited because I know none of this stuff really. I know a little bit about containers, but dashboarding, not a clue in the slightest. So I'm looking forward to learning all this. And obviously dashboards are fun. You can get nice, pretty charts, as you say. But we're doing this on a Raspberry Pi, aren't we? And Raspberry Pis are kind of small, and so they're kind of an easy device to put a little screen on, aren't they?
They are. Ooh, I still have this here.
You still have it on your desk.
Yeah. So you can buy just screens for Raspberry Pis, and they even have like mounting hardware on the back. So you can literally just plug it in, and there's cables and everything there just to kind of connect it to the display. And you literally just plug this in. It turns your Pi on. The Pi powers the display, and it's all good. You don't need any extra stuff because it's all just wired together. But then you could use that and mount it to a wall or something, or Raspberry Pis have an HDMI out, so you could run this to a TV. That's a pretty regular thing that I've seen people do, is have a TV in your team space if you're working in an office, and then just have your dashboards up when you're having your team meeting or something, so you can actually see, hey, here's what's happening. This is what our product is doing. It makes the team kind of aware of how things are actually happening in real time. It also kind of helps show, helps create a communication line between product, the people who are kind of making these decisions and looking at these dashboards, and the people who are feeding the data into them. You can kind of start having those conversations because the dashboard is just there. So yeah.
Kind of becomes just a regular thing that you look at, doesn't it? You see it there all the time. It's like almost like in the first thing in the morning, you look up and do we have any red in our dashboard?
Right, and you can obviously, or you can set up things to automatically look at this and identify issues. You can write scripts to say, hey, this dip is bad, we should send an alert and let people know and automate a lot of that. But actually being able to just aware of like, this is how this works. If you're running a supply chain, you aren't going to be in the warehouse necessarily. You aren't going to see everything happening, but you can actually, using the metrics, you can actually start tracking some of that stuff and getting a better idea of how your product is actually working. Are there spikes that maybe you didn't anticipate? Everything went fine, but there was a spike. Why did that happen? Maybe you should go and check that out. Things like that can kind of raise questions and start conversations that can be helpful.
I guess as well, this is where data visualization specialists really come into their own, because you've got a dashboard that's showing data, but you need to show that data in a way that helps people understand what it's showing. You're not be drilling down to the individual number points. You need a graphical representation that is very obvious when you have problems. I guess if you're looking like supply chain, you could almost have a picture of the supply chain of, here's my manufacturer, and it goes to this, maybe 4 manufacturers of parts, that goes to this assembler, that goes to this packaging plant, that goes to this shipping plant, that goes to the customer. And you can even kind of color those lines depending on whether they're on track or not. So if you see a bright red line between, packaging and distribution, you know that instantly you can see the problem. So you kind of need those data visualization experts to kind of help you really make a lot of power. Otherwise, it's just a chart, and if nobody knows what that chart means, it's kind of worthless, isn't it?
Right, and the other cool thing that one of the things I really like about Grafana is it gives you data templates, which give you a way for if you're working in a larger team and you have a platform team behind you that is giving multiple teams like a Kubernetes namespace to work in, they can provide a templated version of a dashboard that's pre-built for you. So you will just get a dashboard for free that has everything set up for your namespace, and any changes to any of them will affect all of them. So if they add a new chart, for example, about like pods running or pods in an issue, that you can get alerted from that, just because the dashboard is synced to your team. So your team has your own dashboard, but it doesn't necessarily have to be maintained by you. You can have templates of all of this stuff. Even some default templates that you can just import from open source communities and bring in other people's templates and just say, hey, we want to track this too. Here's all the queries we need. So
nice. So I guess for kind of, as you say, some kind of standard use cases like, tracking your Kubernetes cluster, for example. You can have standard templates that you can use for this, and then you kind of customize them where necessary for your specialist use case. And then you have one data visualization team that does all this stuff, pushes it out to everybody.
Right. Nice. Yeah. Because there's things that you typically want to track, like memory on your VMs and CPU usage, 404s or 400 and 500 errors in your response times, things like that you want to know. But you individually making a dashboard for that doesn't always make sense. Sometimes it's helpful if you have a team that actually like controls maybe your ingress points or something like that, and is actually able to do something about that, having those dashboards available and then providing them downstream to teams. So there's a lot of different ways you can kind of structure this. It's very powerful, and we're definitely not going to get all the way into that. But I just want to call it out because it's a really cool tool. It's open source and it's pretty fun to use. So
just to say about dashboards and alerting, just a small funny story. I used to work for a brokerage in Hong Kong, and we had folks who would monitor things like CPU usage. They had little dashboards to monitor things. And we had a big escalated issue that we had a massive problem because they were seeing CPU running at 20% instead of 10%. And so CPU usage has gone up. And what are we going to do to mitigate this? Oh no, my CPU is now using 1/5 of its power instead of 1/10 of its power. What am I going to do? Come back to me when it hits 80 or 90%. Then we may have to worry. But you know what? We've rolled out a new system. It's doing more stuff. So what if it's using 20% of the CPU? That just tells me we're paying too much for hardware we don't need. So, with these things are great to have this kind of monitoring, as long as it's not just, oh, this number has gone up, therefore it's a problem. You have to have that understanding of what does it mean when we do this, and what is the outcome of this, and do we care?
Right. I think that's the cool thing with dashboards. When we look at like metrics and basing decisions based on metrics, that's usually a very condensed timeline. The cool thing with dashboards is they can expand that over a day or a week or a month, or even a year if you're really collecting lots of data. That can help you make decisions about, hey, in January, sales fall off. Maybe we don't need to buy all of this tea. during January or something like that. It can help you make those decisions. So it's just, dashboards are cool, and they're visual, which makes it just really handy. It's a nice reference to be able to just point and say, look, it's right there. There's this big thing. We need to look at that. That's a lot easier than just saying
red thing,
right. Than just saying, oh, my log file is big. That I don't know what that means. But if you have a dashboard that's saying, hey, CPU usage is high, at least you know where to start. So
the thing is, if you've got it as well on a chart where it's gone up from like 10% to 20%, you can see, here's my scale of 1 to 100. It's kind of gone from there to there. I've still got all this headroom. I don't care. You've kind of got that instant visualization of, I don't care about this. And then you can say, well, actually, don't worry about that. Let's put an alert here. If we've hit this, it's hit 20%, it's a problem. No, let's actually put an alert on a dashboard at 80%, and then don't talk to me again until we go over that. You kind of got that great flexibility to rewrite the rules as you go along, almost, to work out what's important and what's not.
Right. And one of the things that I really like is when you have dashboards and you have that data, you can rely on it. You can talk about setting up alerts and saying, hey, we want to know when this isn't performing like it should. And here's what this normally looks like, because you have the data. You can go back and look at it and say, hey, we only throw X number of 500 and 400 and failed requests. If it goes 200% of that, there's a problem. And we should have somebody look at it. Even if it's not actually a problem, somebody should take a look, because that's outside of where we're expecting it to be.
Yeah.
Those kind of things can help you make those decisions and start setting up things like SLOs and things like that. And then getting into observability and all those other fun things that get a little bit more complicated to set up. This can kind of be that first step to kind of get you started and start seeing value from it, and then realize that you can invest more. So.
Cool. Yeah, this is going to be fun. So before we dive into dashboards, though, should we talk about how Jim mucked up Azure Data Explorer?
Sure. Yeah, I'd love to learn.
So what we've got, we have, as I mentioned, we have our Azure IoT Hub. It's running here. It's got messages coming in from our device. And we set up a feed to Azure Storage, and we did this using message routing. So inside IoT Hub, you can go to message routing, and you can create message routing. And we had this store data message routing here set up to send telemetry messages into storage. And this was feeding data into storage. And that was great. It worked fine. We then set up the Azure Data Explorer. This is our Azure Data Explorer cluster. Essentially, it's a load of compute that takes data in, builds a time series database of this data, and then allows you to run queries on this data. And you query it using a language called Custo, which is an open source data query language. It's one I think we invented at Microsoft, and now it's open source, so anyone can use it for whatever they want to do. And so it's supposed to fit into Azure Data Explorer. And where we got to last week is we had this set up. We set up our data feed. So we had a database set up. And in our database, we defined a data connection. And this data connection it was connected to our IoT Hub. So it would pull data from our IoT Hub. And then it would put it into a table. And we had a mapping file that said, this is how you put the data from here into here. And, we've lost Sam. Okay. Bye, Sam. I don't know what's happened there. We've lost Sam. Hopefully he'll be coming back in a bit. So anyway, we set up this routing. So it would be, where's my little picture? IoT Hub, feed data into Azure Data Explorer. And we had a mapping file that says, take this weight value. So this is the weight value that comes from our device. It is, where's my pi? It's what we're sending from our device. We have this weight value, and we'll map that to a column in a table in Azure Data Explorer. So that column is called a weight. So we built this mapping. It's defined with JSON, and we use this to manage our data as it comes in. So that was all good, but we weren't getting a data count coming in. So if I went to query my data, I could say query the count of rows in the database, and nothing was coming in. We got no data at all. And obviously that's a problem, because we want data coming in. So something wasn't working. Although we set it up, we worked through the docs, we followed that, we got the connection right. As far as we knew from the documentation, nothing was feeding in. And there is a reason for that. There's a very good reason for it. And this reason is described in our troubleshoot IoT hub message routing documentation. In the I suddenly stopped getting messages, the built-in endpoint section, which is kind of what we did. We stopped getting messages. Now, IoT Hub has a built-in endpoint. So under Hub settings, built-in endpoints here in the portal, there is an Event Hub compatible endpoint. So IoT Hub has this exposed endpoint. It's compatible with Azure Event Hub, and you can connect to that to pull messages off. So you connect to that as an Event Hub. Every time a message is sent to IoT Hub from the device, it goes to this Event Hub, so you can pull this message off. And Azure Data Explorer connects this IoT Hub compatible endpoint. So it connects to this, and it listens to the messages coming from the device. Now, it turns out when you set up a route, a message route, it actually switches off the built-in endpoint. I guess the idea being, well, you've already said you want to route messages somewhere else. So why bother having this Event Hub publishing messages to no one? So as soon as you turn on the message routing, you lose this Event Hub compatible endpoint. So where we turned on message routing in here, we turned on message routing to store data that puts it into our storage blob. We lost, well, we didn't lose, but that's behind the scenes switched off the built-in endpoint. So nothing was being sent to the Data Explorer. So what you have to do is you have to create a new message route to an endpoint called events. And so I created this new message routing endpoint, events routing, and that sends it to events. And events is an existing built-in endpoint. So you're saying route messages to the built-in endpoint. So normally this is turned on. This happens by default. The messages get routed, but because we added a new message routing, this automatically gets switched off. You have to explicitly add it back to make it work. Now that I do that, messages feed in, and if I go to here, if I go to, there we go, there's data. So we actually have got data now feeding into Azure Data Explorer. So that's the I think the one takeaway here to note. If you use message routing, it switches off the built-in endpoint. You have to explicitly turn that back on again. But what I'm going to do is I'm going to just get this tidied up and dropped in the chat. We'll just get a short link dropped in the chat for you if you wanted to read up on that yourself. So just, yeah, that'll be appearing in the chat in a few minutes, hopefully. So yeah, that's why things stop going into Azure Data Explorer. So of course, now we have a fun thing where this is the part where Sam was going to take over and talk through Grafana and dashboards. And he's now disappeared. So I don't know where Sam has gone or when he'll come back. So should we just kind of make it up as we go along? What does everyone think? Should we just try and make it up and see how far we get until Sam gets back? I'm imagining some kind of weird internet issue has affected him. I've been getting weird internet issues for the past couple of weeks. Suddenly dropped to reboot my router before I even started today. So, I mean, I'm hoping that I'm the one who's still on. It's not me that's got lost. StreamYard still think I'm seeing here. So say hello in the chat just to make sure that I'm not talking to no one and I'm not the one who's been dropped off. So let's talk about dashboards with Grafana then. Let's just dig around a little bit. Say I know nothing. So we can dig around a little bit into this and see what we can do to maybe get a bit started for now. Okay. Cool. Yeah. Okay. I'm good. I'm told I'm good. I'm still here. Yay. That's cool. So we do have in our docs for Azure Data Explorer, we do have some how-to guides. And these how-to guides cover a wide range of things. So we used these last week to ingest data from IoT Hub. So that got us data going in. We can now use this to we can now follow a how-to guide to query data, to visualize data. so on and so on. So there's a lot of really good how-to guides to kind of get us going. And there's one here which explains how we can visualize data in Grafana. There's a nice little video here. No idea how useful this is. Oh. Okay, probably not going to come through very much. We wouldn't want to sit here and watch a video together. But let's actually work through this together and see what we can do to get Grafana set up. So I guess the first thing I need to read this bit at the start is what is Grafana? Because I mean, I know it's a tool for doing dashboards. I don't really know anything else about it. Sam, the elusive Sam who's disappeared is our expert on this. So Grafana is an analytics platform enables you to query and visualize data, then create and share dashboards based on your visualizations, which I guess is what we talked about earlier, what Sam was describing. We can build a dashboard, put like charts and graphs and pictures and all that on there, and then use that to visualize the data. And the data we visualize comes from some form of query. So we write a query that pulls out our data, and then we can plot that in Grafana. So yes, apologies everybody. Eric, yes, hello. Sorry, things being dropped off. Thank you much. You're starting cybersecurity, new to it. What did you expect from cybersecurity? I don't know much about cybersecurity, so I'm not sure I'm the best person to answer. Sam, any tips for Eric starting new with cybersecurity?
I think so. There's a lot of people on Twitter I know who talk a lot about security. I could find some references, but that's typically where I've found it, is just trying to network with people. But it's not something I'm very familiar with. But I have found that community seems very open and helpful. So that could be a really, really good place to go, is just try to connect all of that.
And one person I will recommend on Twitter is Tanya Janka. So she hacks purple. In the world of cybersecurity, they have like the red team and the blue team, depending on what type of hacking you're doing. And she's purple because she's kind of a mixture of red and blue. But she's absolutely brilliant. Someone to follow. Does a lot of cool stuff. Really pushes. There's a whole. I can't remember. There's a whole acronym for some really for cybersecurity stuff that she does a lot of stuff with that.
OSINT, I believe, is what you're looking for. OSINT?
OWASP.
OWASP?
OWASP. Okay. Yeah. The OS kind of got the OWASP. But yes, it's well worth following Tanya. So cool. Yep. Hello, Manju. Hello, Orange Madness. Hey, Lisa. Glad you can hear me. Kwesi, hello in Tampa. Hello, everyone. Hello, everybody. Loka, hello again. Yep, cool. I'm back. Yes, you can see me. You can hear me. Brilliant. Brilliant. Excellent. Cool. Cool. Thanks, everyone. So, yeah, so apologies for all the madness. Sam, just to catch you up, I was left here by myself, floundering, going, I know nothing about dashboards. What am I going to do? But I did talk briefly through the Azure Data Explorer problem. I will talk through it again, because I bet Sam's probably itching to know what it was. I discovered this Friday night, and I haven't told him the secret yet. So what it is, Sam, if you remember, we set up a message routing, didn't we? To store data. We set up the message routing in IoT Hub that automatically copies our data into our storage account. Now, when you set up an IoT Hub, you get this built-in endpoint, this Event Hub compatible endpoint that anyone can connect to and pull data off. Obviously, anyone with the right permissions, the right keys and all that can connect to it. And Azure Data Explorer connects this Event Hub compatible endpoint to pull data off, which is very useful. It's very cool. Only it turns out when you read the I suddenly stopped getting messages, the built-in endpoint section of the troubleshoot message routing documentation, whenever you set up message routing, it switches off the feeds to the built-in endpoint. Okay. So where, I guess it's because if you've got message routing, you're saying, I don't need this built-in endpoint, I've got message routing. So where we set up the message routing to storage, that switched off the Event Hub compatible endpoints and nothing was going into Azure Data Explorer. The fix is to re-enable that, which you do by adding a new message routing to the events endpoint. And if I actually click on this one, built-in endpoints, events. So you actually set up a new message routing to send those messages through to events. So that way you get the feed coming in. And that way that by having this enabled, we still have the feed going to the storage account. We have the feed going to the event hub bottle endpoint, and that then feeds nicely into Azure Data Explorer, and the data's there.
Okay, that makes sense. We have a comment about screen quality. You could zoom in. It might also be a setting on your side, Manju. So sometimes YouTube will reduce the resolution that your stream is getting. So you might be seeing that.
But we can definitely, I mean, I'll zoom in a bit more so we can see. It's a problem. Trying to get everything on screen as well. There we go. So,
okay, so we can query weights now. Perfect.
So we can query weights. So we can do all the various custo queries. We can take 10. We can do count. That's the basic one. IntelliSense. This is very nice. Returns the number of records in the input record set. Gives me all the details of that. Run that. 959. And so that should slowly, over time, that should build up because we're still feeding in from here. We've still got weights going in. I'm going to restart my scales. Definitely, the way I've got these scales set up, they're definitely not the most accurate. The way I've got it done is I've got this foam block with scales underneath. I don't think where the foam kind of deforms slightly with the weights on it, because it only takes very subtle movements on the sensor. I think it kind of gets a bit deformed. So, ooh.
Yeah, for people who aren't familiar with these, they are little metal sensors, and inside of the metal, there's this white blob of goo that's hiding a microcontroller that measures the bend of the metal. And so that's how these scales work, is as the thing is depressed, it bends the metal, and that is picked up and changes the electrical currents, and we use that to adjust for weight. So these have to be calibrated in order to work. But then once you get that, you get a reading back out that will tell you what any of this means. And then you can use that to kind of pull your weights out. So there's 4 of these on the back. But because of that, anything else that also bends can influence this, because it's just bend. So if other things are bending and not the scale, then maybe not the best reading comes back. So
yeah. And whereas that one, I've got a block of foam because I should have got a nice square of wood or something solid, but I had a block of foam to hand. I used that, and now I'm regretting it. So yeah,
mine is it's off the screen. Is a block of MDF with some acrylic in between, and then just some screws to hold it together. So you can do whatever you want with this. It's really up to you as far as designing like the scale part. If you want to do this project, especially if you have a Raspberry Pi just kind of sitting around, they're kind of hard to get right now. But if you just have one, the scales aren't very expensive, and so this project becomes pretty accessible. So that's one of the cool things with this is cost wise, it's actually not that high. So
yeah, for the hardware that you're using, Raspberry Pi is a full-featured Linux computer. It is relatively inexpensive. It's not cheap. They're supposed to start like $35 and obviously go up from there, especially at the moment where supply chain is limited. It's like $100 potentially for some of these boards because they're hard to get. But for the hardware, they are relatively inexpensive. So it's a good setup. Now, so Sam, whilst you were gone before I got kicked out, we were looking at this how-to guide. I'm just kind of talking through this, and I was kind of like, I don't know what I'm talking about. So let's kind of work through the guide and see where we end up. So really, if we can drop this guide in the chat, that would be awesome.
Let me see. I can do that.
If you can do that, that'd be cool. And then, do you want to talk through what this Grafana thing is all about, and we can work through this?
Yeah. So Grafana is a open source dashboarding tool. It was originally designed as a way to just visualize time series database things. And so how it ends up working is you can pull in data sources from anywhere that you want, write queries against that data source, and then get a visual representation of that. So you can map, for example, things from a SQL database or a Mongo database or NoSQL or Graphite or I'm forgetting other time series things, but other databases. You can just pull from other data sources and get that visualized. You can also pull from other logs and things like that to visualize those as well. So it gives you a way to just write queries against different sources of data and then create a visual representation of those. So what we're going to be looking at is we've put everything into Azure Data Explorer. So we're going to be setting up Grafana in a container running on our Raspberry Pi. So we're going to need to get Docker running. Docker is one of the ways you can run containers on Linux. There's a few different ways. Docker is sort of the front end that you see. And behind the scenes, it's usually containerd, which is the daemon that runs containers. And so Docker talks to that and schedules a container and says, hey, run this container, and does all the API stuff. So when you run Docker logs something, that's what you're seeing. You're seeing it interacting with that daemon behind the scenes.
So you say, so there's a couple of words there,
Yeah.
which I kind of just sort of understand. So containers and daemon. Now, daemon is the dude from The Omen, filmed in the cathedral behind the university I went to. So I'm not sure what he's doing on my Raspberry Pi, but also a container. That's like a big tub, has tea in it, sits on top of the scales, right? So I'm assuming you don't mean those. So what is a container and what does daemon have to do with it?
So daemons are something I'm actually not super familiar with. I think of them like services on Windows. So if you run a service in the background on Windows, I think of it very similar to that. It is a process run in the background to kind of handle things. In this case, it's the container runtime. It's what's actually running your containers and doing all the magic containery stuff. Containers is somewhat confusing, but I guess the best way to think about it, I don't know if it's the best way, I'm going to say it's the best way, is a container is a way to isolate different things. It's a reproducible instance of something. For example, if you have your computer and you've set up your computer perfectly, maybe it's your home computer, maybe it's your work computer, whatever, you've installed all your custom tools and done all of this. A container is based off of a container image, which is going to be a blueprint of, I want this to look like this. So run these things, do these things, set up this environment, do all of this. And then that is actually going to interact with Linux or Windows. You can run containers on either system. They're not compatible with one another. So if you are running Windows containers, you can't run Linux stuff. Same way the other way around. But that's pretty much how it works. Is it gives you a blueprint of something that you want to create. So we're talking about creating a Grafana container. So we're going to go and look at a Grafana image, pull that down, and then take all the steps and run through each layer of that container to recreate whatever environment that was. And so the cool thing with that is it means you can recreate it. So you can run a container, and I can run a container, and we can run a container in the cloud, and all three will get set up the same.
Okay, so it's sort of like a virtual machine in some ways. It's kind of like it's a computer that runs on its own inside your computer. Though virtual machines are different because I can run a Linux virtual machine on Windows. I can run a Windows virtual machine on Linux, install like a VirtualBox or something and just say, run Linux and this. And I've got like a Linux computer running in a window on my Windows box or what have you.
Right. And that's a pretty common analogy that I think a lot of people draw is they say containers are like lightweight VMs. They're a little bit different. Unlike a VM, which is everything is virtualized, containers don't necessarily do that. You're using your computer's network. You're using your computer's Linux kernel. That's shared with your containers. So you're not spinning up an entirely new thing. That's why you can't run Windows on Linux, for example, because you're trying to share that kernel. And it's just not there.
So if you have a Windows container, there's no Windows inside it. It uses the Windows on your computer. It just everything else is inside it. So it just uses the Windows on your computer. It doesn't use all the other applications you've got installed.
Yeah, Windows. I'm not as familiar with the Windows side of containers. They are a little bit more unique than the Linux side, which is the one you're probably commonly going to see. Typically, what I've seen Windows containers used for is like running a maybe you've written an ASP site and you need to interact with Active Directory, for example, and you want to domain join your containers so they can actually interact with your domain. Things like that I've seen used. Less common other things. Windows containers tend to be larger, and that can be a difficult thing because when we're talking about the cloud, one of the things that can interfere and cause things to take longer is if you're transferring big files back and forth. So if you need to download a 200 megabyte file instead of a 10 megabyte file, that might take a little bit longer to do. And that can actually impact things like startup time because you need to download everything first. And it can just, there's more resource overhead, for example, things like that. So if you need Windows specific stuff, look into Windows containers. If you don't, I recommend using Linux containers. They work on Windows. You can run Linux containers on Windows. It just works. So it's all fine. It's just there's two different things, and sometimes you need something that relies on Windows stuff. So that's what you would need that for.
Okay, so I'm just I guess saying from a Linux perspective, then it's if I run a Linux container that uses the Linux kernel on whatever machine it's running on, be that a Linux box or I guess what the Windows subsystem for Linuxy thing. So if I have my Raspberry Pi, which has got Linux, if I put a container on there, it'll run the it'll use the kernel from the Pi. But if I from my container, if I run Python, for example, it won't find Python that's installed on my Pi. It'll just, because that has to be in the container, it'll just find the kernel.
Right. And it gets a little bit more confusing because things can be shared. We're actually, with this solution, we're going to be sharing things because containers are, there's a word that people use for this, and I always forget it because it's confusing, but containers are largely stateless. Everything in your container should be something that you're comfortable with going away. And obviously we're storing dashboards. That's probably not a good thing to just go away. We don't want to install and add all of our users, set up all of our dashboards, and then decide we need to change some configuration in our container and lose all of it. So that can be a hiccup that you can run into. Same with like networking, for example. Containers can be useful because maybe you want to host something on different ports. So if you have a bunch of web services that are all hosted on like port 80, they're all published to port 80. If they're all in separate containers, you can publish those ports onto your own host machine at different ports. So even though all of your processes inside of these containers are saying, we're going to take port 80, they're all on their own network. And so they're not interfering with one another.
So you can say, if I hit port 3080, go to port 80 in this container. 4080, go to port 80 in this container. 5080, go to port 80 in this container.
Right. So you can map things to different places, and your host machine can kind of control that. Or you can network things internally, which is one of the really cool things. If you start doing more advanced things with containers, if you have multiple things, multiple containers, for example, you have a website and then you have some backend service that your website needs to talk to, but you don't need to be open and public to everybody. You can put those on the same network and refer to the backend service using the name of the container. So you don't even need to know ports or anything. You can just say, talk to this, and it will go and be routed directly to that service. So there's some really fun things you can do that way.
Cool. Now, Fuel Snowbell says, whenever someone says it just works, I assume it never works for me. And that is a very, very good assumption. Yes. So Sam, come on, you've got to clarify. So when you say it just works, what do you mean by that? How?
Oh no. What did I say it just works for?
Running Linux containers on Windows. You said it just works.
Oh, so There is a feature in Docker for Windows. If that's typically what you're going to be running, if you're on a Mac or Windows, typically you're going to be using Docker as your front end. There are alternatives like Podman, which is an open source alternative that will do similar things. But Docker has been the most common and is more user friendly, at least for now. And so on Windows, there's an option to select which type of container you want to use. It's a setting inside of Docker for Windows. And you can say either use Windows or use Linux containers. Because of that, you can't use them at the same time. So there's that option. Kubernetes also supports Windows containers. So if you want to run your Windows workloads inside of a Kubernetes cluster, that's possible as well. But those need to be separate Windows-based nodes in your Kubernetes cluster. So it just gets a little bit confusing. But that's how it ends up working. You can also, again, you mentioned doing WSL. If you want to use WSL for Docker, recommend upgrading to WSL 2. You probably will get a message if you try WSL 1, if you have some old WSL stuff. Windows subsystem for Linux, if you're unfamiliar. But that lets you run Linux workloads, like real Linux stuff on Windows. So you can run graphical applications, you can run cron or whatever. You can just do that from Windows. So you can do that from WSL 2.
Right. Okay. So I guess really then the caveat was it just works providing you just use Linux containers.
Yeah. I suppose. Containers can be weird. I mentioned there's that daemon behind the scenes. We will run into some issues as we're setting this up to actually get everything up and running. That's going to cause some issues, I think, just because of how all of it works. So we'll probably run into some things there. And as long as the daemon is running, you should be good. If it isn't running, check your install and make sure everything's good. Sometimes you may need to either restart it or just try to get the newest update if that's what you're running into. But I haven't had too many issues with it, so.
Okay, cool. Okay, and Fuel Snowball says WSL was huge for me. So
I'm a big fan. Historically, I've always worked on Windows. It's just been the platform that I grew up on and I'm familiar with. But then you become a developer and everybody's talking about Linux, and you can't do any of the stuff. You try to curl something and it really doesn't work. Or you install something that is, I think Git for Windows includes things that kind of map some of the Linux-y stuff to Windows stuff. So it's compiled for Windows. And that works, but then none of the scripts work. So if you try to use like Z Shell or Bash, might work, but it might not. WSL fixes a lot of that, and it just makes it super easy. So if you want to be a Linux developer and you have a Windows machine, it just works. I said it again, but this you can actually just go onto the Windows store and say I want Ubuntu, and it will download Ubuntu for you. So
why not just install Linux instead of Windows?
Well, because sometimes, let's say you like the Windows UX, you like using Windows, or you need Windows for, maybe it's a gaming PC and you're playing a lot of games, for example, on Windows, like I do. Maybe that's your use case, or just you have a Windows machine because that's what you have. And so if you don't have a choice, it can be a good option. But it also just gives you that freedom to choose. If you like working with Windows, you can do that. If you like working on a Mac, you can do that. If you like Ubuntu, also works. So
Fuel Snowball says, my MacBook Pro fell apart during Corona, but I could switch to my Windows box through development and liked so much I never used the MacBook again. Huh. So there you go. I'm Mac OS through and through. I'm very firm in the Mac OS camp. But yeah, no, it's great to hear that you're able to do that. That's one advantage, I guess, with a lot of these technologies that are cross-platform, is it doesn't actually matter what platform you're on. You know, I mean, I write Python code on my Mac, but you know what? I can just put that on Windows, and it most of the time it just works. You know, as long as I installed the right Python thing, it just works. But yeah, it's kind of good that you can just take everything, a lot of what you do, and go from platform to platform to platform.
Right. One of the cool things with that is you can run multiple versions of Linux. So it doesn't just have to be Ubuntu. You can run OpenSUSE and Ubuntu and Debian and anything else that you might want, which becomes really handy because then you can just say, I want to do this on this machine. Maybe you have one for school, or maybe you have one for a specific environment or something like that. You can start spinning these things up and kind of working in different environments to kind of figure out why things are different in different places. So it's cool. Highly recommend checking it out. It's one of my favorite features that Windows has added for developers. So
cool. Okay, well, I guess though, just thinking about this, before we dive into Grafana, you're saying about this Dockery stuff. Should I get this installing on my Pi?
Right. So we can install Docker onto your Pi. Again, Pis are ARM architecture. So that gets interesting because again, we're sharing the kernel. So you can't just go and run anything on your device. That's not quite going to work, but this should just work. So actually Docker has an installation thing for Debian that just works, or should work for your thing. If you just you can try that. I don't think that works. I think with Podman it is that simple. You can just do apt-get install Podman. But Docker has some documentation on how to do all of this. I don't know what you're going to get with this. Yeah. Yeah. Honestly, I'm not entirely sure what that does. what that package does, because I made that same mistake last night when I was trying to figure all this stuff out and trying to understand. Like, I haven't done this in a few months. How does this work? So if you go Raspberry Pi, you should just be able to use the Debian version. So they will have a install Raspberry Pi or Docker install with Debian. I can share this in chat, so people can just kind of
old versions. So that's all these instructions. Just thinking if I get this going now, in case it takes a while we do the other stuff.
Yeah.
Let's uninstall the old versions as the instructions say.
All right. So here is the docs that we are looking through. This is just the Debian install instructions. It's going to have you set up a apt repo to actually pull from because it's not in the default apt thing.
Okay. So if we start with an apt update, can't hurt to do that.
Yeah, there are 3 different ways to do this. So what you're walking through right now is installing from a repository. So you're going to set up apt and then pull from apt. They also, if you scroll further down, they do have a convenience script that you can just curl to pull down and then run that. And it will run some of the stuff for you.
So we just do that?
Yes, that is their preview thing. So that will dry run it. But if you just do the top one, then you can, that'll pull it down and then you can just exec that.
If I do that, and this is a dry run thing to do the work. So if I run this, it says it needs sudo. That does a dry run, which does nothing.
But then if you just run this, it should weird. So it's gonna run this. I think it might wait a bit, but yeah, this is gonna do all the same apt stuff. It's just automated for you. So this will run through and set all of that up for you. And I think it also creates the Docker group, which is required if you want non-sewer access to Docker. So by default, if you just start trying to run Docker, you're going to get an error that the daemon isn't running. That doesn't necessarily mean the daemon isn't running. It means you don't have access to see that it's running. So we are a sudoer with our Pi, but we aren't necessarily running as root. That's why you have to sudo things. So there's 2 options. You can run all of your Docker commands with sudo, which you probably don't want, or you can add yourself to the Docker group that gets added with this script. And that will allow you to do all this fun stuff. So that will fix the issue. You can just try if you follow this. I think it has you run hello world. If you just run that without sudo after this finishes, it should show you some issues. That's in the wrong spot. But anyway.
Yeah. Okay. So we'll run that. Oh, it's done. So if I go Docker.
So you do like Docker PS and you'll get this. So permission denied, trying to access this. If you use Docker a lot, you'll get familiar with that message because that happens anytime. If Docker shuts down for some reason, this can happen on Docker for Mac, Docker for Windows. It can just get shut down on you. You'll need to restart it. Otherwise, you don't have access. You're not part of the Docker users. So
this is what it says. There's helpful instructions here. So when it's installed, it's actually put these helpful instructions here. To run it as a non-privileged user, consider setting up the Docker daemon in rootless mode for your user. So should I just do this?
I have no idea what that does, but sure. What does it do?
On the phone, missing system requirements.
I don't know what this does. To be entirely honest, not very familiar.
So let's just do that. There we go. And as Fuel Snowball says, just run as root. No need for sudo. No.
Where is the thing for post installation? So there's post install steps. Where are those optional post installation steps? On the left hand side, right below.
Here you go. You do need to install new UID map and new GID map on the host before you can then do the thing to do the thing. So it was a quite helpful message here. It says me to do this. To me to install that. So if I do that, that installs the thing. Then if I go back to here, done. So if I go Docker PS,
you might need to restart. Reconnect your session, just so that the permissions catch up. But I have never run what you just ran, so I have no idea what happened. But there's a question in the chat about, do we really need Docker? And the answer is no. No, we don't. You could just install Grafana and it would be fine.
Mm-hmm.
There's no big issue with doing that. The advantage of Docker is it isolates, or the advantage with containers is it isolates different things. So if we start adding different components to this, we can isolate them and prevent different configurations from influencing different things. It also makes this reproducible. One of the cool things that means is that if we want to explore different Grafana setups or something, I can take my configuration for this Docker image and run it locally on my machine. I don't even need to start up my Pi. I don't need to connect to it. I don't need to do any of that. I can just explore and tinker and set things up on my machine and then deploy it to the Pi. And that gives you a dev and a staging environment that you can kind of explore and do things like that. Also, containers give you a nice isolation. They make it a little bit more concrete, so that things that work in one place should work in another place. One of the things that I've always run into, especially with like Python, for example, where you have Python and Python 2, Python 2 and Python 3 rather, that can sometimes conflict with one another. That can cause weird things to happen. So that's I think the idea here. Also, it gives us an excuse to kind of play with containers. But if you want to solve this a different way without containers, that's totally cool.
It does mean as well we could take whatever file we use to create the container, we could put it on GitHub, couldn't we? Obviously, removing any environment variables or what have you that we put in there that's specific to our Azure Data Explorer. But yes, we could then share the Docker file with everyone and anyone can reproduce this.
Right. Well, so that's actually something that I really enjoy, is using configuration as your source of truth for your project configuration. We didn't talk too much about this with the Azure portal stuff, but you can also set that up through ARM. So the Azure Resource Manager can actually give you a reproducible template of everything that we've set up so far in this project, which means that you would be able to just move this to a new resource group, or give this to somebody else and they could spin that up. Same thing with like Docker Compose. We could set this up so that we have Docker configured, we have our container configured, and then any changes to that configuration are synced through GitHub, and then we can use CI to deploy this. So it gives you those different options. Obviously, that's not required. You don't need to do that. And it does complicate things. It adds another layer of abstraction. So it makes it more difficult to do from the start. But it can give you some nice architectural stuff in the future. So
cool. Okay, cool. So I got Docker there. I was doing that just in case it took forever, but didn't. So we're good. So let's go back to Grafana.
Cool. Well, before we do that, let's make sure your containers are running, because this is a nice kind of way to just make sure things run. Is just if you do Docker run hello-world. It's going to actually kind of walk you through the initial container setup. This actually is just going to run a bunch of echo commands to run a container and then echo out what it did. But it's going to pull down a new image because you said run hello world, and it had no idea what you were talking about. So it went out to Docker Hub, found an image that matched that name. It inferred that you meant the latest tag. Tags are a way to differentiate images. So we talked about images as sort of blueprints of what you want. Things upgrade over time. So if you're talking about .NET, you might have .NET 4 or you might have .NET 6. Things like that, you want those to be different tags so that they mention different things. The default is going to be latest, which is the most recent push of the image. So that's the most recent version. You probably in a production environment want to tag it to something explicit. So again, you can reproduce it, because otherwise if upstream gets updated, suddenly you're going to pull a new image that doesn't match what you had previously, and then you get weird upgrade things that you may not have anticipated. Especially in a container world where you're trying to be stateless, the intent is that things can restart on you. If your server restarts at 2 a.m. and then tries to pull an image that never existed before, that you've never seen before, that you've never tested into your production environment, you probably don't want that. So latest is the default. Oh, go ahead.
Let's say, so if you're on like Hello World 1.0, for example, and then Hello World 2.0, it actually has a breaking change in the API. You want to make sure you're putting Hello World 1.0, because if you accidentally pull Hello World 2, everything breaks. Right.
And this way you can also, a lot of environments have multiple services that are going to be running in different containers with different dependencies between them. This gives you a way to control that without having to do everything. A lot of times I've seen it pinned to, say, a commit SHA. So it's tagged with whatever the hash is of your commit in source control. So when you spin up a release, it's just tagged directly with whatever SHA that was, something unique. And then your CI handles that. It doesn't have to be super nice. Other people will use semantic versioning if it's something that needs to be human readable. You can do whatever you want. So
I guess with semantic version as well, you can say, well, it doesn't matter whether I pull 1.1 or 1.2. I know that my contract is not changing, so I might as well pull the latest one inside of latest version of 1.
Right, and you can see some of these SHAs in your output there. You can see that 9B157. That's some intermediate layer. I guess that's there. Then there's also the image that gets started with, which is 9.7 something. You can use these. You don't have to do the full thing in Docker. It will infer if it can match them. But you can use that to find like stopped containers, because this ran typically Docker images or containers run a single process. That's usually best practice, is to have a single process inside of your container, maybe a web service, maybe Grafana, maybe a bash script, just one thing, because when that process stops, your container stops. And if you have two things and like you have a web service and then you have something in the background that's doing a monitoring on that, your web service stops, but the background thing is still going. Your container might still keep going. And you probably don't want that. You probably want some notice that this isn't very healthy when that web service stops. So you typically isolate those.
So I guess another difference then between a container and a virtual machine is if you spin up a VM, you might run multiple services on the VM, but really for a Docker container, you just do one, but you'd have multiple Docker containers.
Right, and because it's sharing everything, these images are not very big. This is like a few megabytes, I imagine. You could do Docker images ls, I believe, to see what that's actually doing. Or there's nothing there. I forget the thing. Let me hold on.
But am I just running this, or have I actually downloaded this?
So when you pull the image, you pull it locally. So if you run that same thing again, if you do Docker run hello world, it will look different.
Cool.
None of that pulling stuff is there anymore. Which also means, since you have a copy that says this is the latest version locally, even if a new version of the latest image is pushed, you already have latest, even if it's not the same. So you're not going to pull the new one. This is a gotcha that I've seen in the past. So something to keep in mind if you have tags that conflict. So
you do want to, you don't want to tag things by version number or something, and always use that. Latest feels like a terrible thing to use.
It can be useful when you're getting started, but it can also confuse you. So,
so Go 0mback has said Docker images -a because the container is not running. So there we go. Thank you very much. So we can see from here, yes, this is our container. It's 4.85 kilobytes. Again, substantially smaller than a virtual machine.
Yes, this is not your container though. This is your image. So this is that blueprint. Okay. You also have containers, which are stopped and can be restarted, things like that. So they have a state. You can start things. That's typically when you do Docker run. You're starting something. You're saying run this thing, and then you might want to stop it at some point, but then you can restart it. So there's two real ways you can kind of do that. You can either create a brand new thing. Anytime you change any configuration of your container, it's going to create a new container. So if you want to expose a new port or add an environment variable or add a volume, it's going to recreate whatever that is for you. So that's what's going on there. Containers PS, I want to say, nope. You can tell I use these commands a lot. So what is it? Well, if you want to explore these, you can do Docker help to get more help, and that will actually show you all of these different commands that we're looking at. And that's the list of them. So you have logs, you have images. I am completely blanking, and I don't know why, on what this is. You have management commands at the top there, which are going to help you manage different things. So I think it's Docker here. ls. There we go. So Docker container ls will list your running things. That's what I was looking for.
Docker container ls, that's the one that's running, but it's nothing running.
Right, because your container stopped. So
this is why Docker images -a lists that as an image.
And so you can also use that -a with this containers command. So you can do Docker containers ls -a. And that's going to list all of them. And you have two because you ran this twice. Right? And so there are two different instances of this. And you'll see they have different IDs and different names. The names are just randomly generated to make it a little bit nicer for you. If you don't give it an explicit name, you get something like Wonderful D-Rock on the right there.
Stupefied Villani. Yeah, nice.
Yeah, so you get weird names. You can use that name, or you can use the container ID on the left, they will both refer to the same place. One is just a little bit nicer to say than 8C0B, whatever.
If I go sudo docker run wonderful Dirac.
So what it's going to do is it's going to go and try to find an image that matches that name.
Okay, so that won't run a container they've already got.
Right. So these are in the stopped state. They have been stopped on your thing, which means they can either be removed, which will clear up any state that they have. So anything that they've saved. Docker PS also works. Docker container, that's a shorthand for Docker container LS. So either one of those will work. I just completely blanked on PS for whatever reason.
So if I go for sudo docker restart on wonderful Dirac.
So you're going to get the name back, but if you go and look at logs, I think you might see something. So Docker logs, and then the name of the thing.
Okay, so the container's not actually doing anything when it runs. This is just being output by...
Well, no, it's because you got the output again, because you restarted it.
Yeah,
right?
but the container stuff doesn't explicitly dump stuff to the console because it's running in its own thing, isn't it?
Right. Right. So the default when you run it is going to be attached. When you do Docker run, it's attached. So you will be tied to that, and if you like Control C to cancel the process, it will stop the container for you. If you pass in -D, it will run it in the background in without you getting any input. You'll just get a name of the container back. So you can give that a shot too.
Like that.
Before the name of the image. That's the last thing in the arguments. So run -D. And there you go. So you just started something, you get some crazy thing. You don't need to copy all of that. You can probably just take the first 4 letters in that. So FB17, and you'll get the output.
Okay, cool.
Cool. So that's intro to containers, I think.
And, Chris says, and now you'll never find it back again. It's like, yes. Run all these containers and we'll see all these IDs and we'll never know where they are again.
Yeah, so you can clean them back up. I recommend doing that, especially if you're running, especially with Windows containers, if you're not using the smaller versions. The image size with Windows containers has gotten much smaller, but they are still very large, especially compared to this Hello World example. So you can burn up a lot of hard drive space just starting these containers and then just leaving them there. I believe if you do Docker run with an RM argument in there, it will be removed as soon as it's run. So you do Docker run RM. Let me just make sure. Dash RM. Sorry, because it's 2 letters. And so that ran, and now it won't exist in your containers. So you don't have it.
I had Hardcore Edison, Sleepy Shore, Stupefied Villani, and Wonderful Dirac. And now I still have Hardcore Edison, Sleepy Shore, Stupefied Villani, Wonderful Dirac. I don't have a new one.
Right. And so that gives you a way to kind of run these things really quickly and do all of that fun stuff. There's a whole bunch of things we could explore here. One of the other cool things, you can use containers as development environments. So you can set up a developer environment for Python or C# and install all of the fun extensions that you need. Hand that out to your team, and then everybody has everything configured for a developer environment without, they can do all the cool stuff they want on their own PC, set up everything, install all these cool tools without breaking the actual developer environment for your tool.
Isn't that what Codespaces does? GitHub Codespaces? Because you have like a container file in there that says what stuff you need. So when the Codespace starts up, it's got all the stuff.
Yes. Yeah, that's how that works.
Nice.
So lots of fun stuff.
And Chris says, add your user to Docker group to avoid using sudo. Yeah, earlier on we were running a whole lot of commands that were supposed to do that automatically.
So if you want to do that really quick,
how do I do that?
Sudo user mod. Sorry, my voice is weird. User mod -ag, capital G. Yep, capital G. And then Docker, and then $user or pi, whichever one you want. And there you go.
Now
So
if I
you're
go
part.
here-
Now you're part of the Docker group. You may need to restart your connection here.
Okay, so let's create a new, let's add a new terminal, and then, nope.
Okay, weird. I'm not sure.
I mean, I can try $user.
Yeah, that should be the same as pi. Because it's just going to dynamically grab your user. Yeah, I restarted my pi to make this work.
So it could be Docker's already running as sudo rather than as me.
Well, so this is allowing you to access that. This isn't. I think the daemon is still going to be running in as the root user.
We need to restart the entire VS Code remote connection, says Acris.
Yeah, that's what I had to do. Is I gave it a restart command. If you want to keep using sudo for now, that'll probably be picked up in the next episode. So we can keep tinkering with Docker, or we can start doing some more advanced stuff.
Let's do the Grafana stuff. Let's do the Grafana stuff. That's what we're here for.
Cool. So we haven't really talked too much about Grafana.
Usually when you do use a mod with VS Code terminal, you have to restart VS Code. So top tip from Acres there. Okay, thank you for that.
Cool.
I'll be restarting VS Code for next week's show, so we'll do it then rather than now.
Cool. So I'm gonna drop this walkthrough that Grafana has for setting up Grafana, and then we can actually jump into this article that you have pulled up, which is going to walk through how to actually get Data Explorer into Grafana. So we'll kind of walk through a few different things. So for this, Grafana has two different images. There is Grafana.
It's not letting me copy that from the. Can you drop in the private chat? It's not letting me copy that from the public chat.
Sure.
Thank you very much.
Oh, without highlighting it. Okay. So there's two different options you have here. You have Grafana Enterprise and Grafana OSS. Grafana OSS is going to be the open source version. Grafana Enterprise is the enterprise version. You can use Enterprise without paying for it. It just gives you an upgrade path to the paid version, which would add things if you want to interact with other paid telemetry solutions. Typically, those are built into the enterprise version. So if that's something you're using, if you're using Datadog or something like that, and you want to start pulling those in, you can use that. We can use either one, and it should just work.
Sorry. Just excuse me a second. I'm just going to drop off the chat for 1 second. Sorry.
All right. So I will keep talking quickly to kind of walk through this. And so Grafana gives you a bunch of different ways to interact with telemetry. It allows you to build dashboards. So we're going to be looking at is setting up how to actually run these things. So we're going to be setting up a Docker image of Grafana, which is going to let us run this inside of a container. We just got Docker installed so we can run containers. This will give us a way to actually run those. Then what we're going to do is kind of experiment a little bit with this. So there are a few different things going on to actually make this whole thing work. So we're going to be playing a little bit with that and kind of tinkering with some of the gotchas. I mentioned in the chat previously that Docker containers or containers in general are intentionally stateless. You typically do not want state. Welcome back.
Hi. Yeah. Sorry about that. Sorry.
No worries. It's one of those days. So you can set up anything you want. In this case, we're going to be picking one. The default image for all of this is from Alpine. There are two versions typically when you're looking at containers. There's going to be an Alpine version and then a Ubuntu or some other Linuxy, more familiar flavored version. Alpine is typically smaller. It's going to have a lot less dependencies. So Grafana is, you don't necessarily need code. So if you're looking at running things in code, Sometimes it has a visual thing. If you're interacting with certain things, it will give you a visual thing. Azure Monitor is supported by default, and that has a click. Just select this, select what subscription you want to look at, select the metric that you want to track, and you're all set. You don't need to code anything. You can also use code. So if you want to write code that just runs this SQL query and classifies it in this way, you can do that too. I wouldn't say Alpine is magic. I think that it's just smaller. It doesn't have all of the like glibc, a lot of the default stuff that you would get from a normal Linux install. So if you're used to most normal Linux tools like curl, bash, things like that, Alpine may not necessarily give you access to the same tools. It requires different stuff. But because of that, you get a much smaller image. And because we're kind of setting this up to be stateless, it matters less here because we're going to have one thing. But if you typically with containers, you might be scheduling this across a host of machines. So you might run on one machine and then that machine goes down and you get scheduled somewhere else. Every time that happens, you need to pull the image back down. And so the size of your image matters. If you're pulling too much data down, that increases the time it takes your downtime because it's going to take you longer to pull down the new image and set it back up. So just considerations. And also if you're starting a bunch of containers, you're going to burn through your space faster. You can clean that up. There's a prune command to remove stopped containers. Recommend running that every so often, just so you don't have like a few hundred of these things just laying around not being used. But anyway, for us, we should just be able to grab this Grafana OSS version. Jim.
Okay. So should I just do a Docker put on it, Docker run? How do I grab it?
Again, this gets into some of the weird things. You could Docker run this probably. You could probably just grab that and do Docker run. I think we want version 8.2.0 as far as tags are concerned. Latest would also probably work, but I haven't tried that. But it won't work. So you can run that and it will show that it's working, but it won't be working.
Won't be working. Okay.
Yeah. If you want to see, give it a shot. But this runs into some of the networking stuff that are kind of quirks of containers. So that's going to pull whatever the latest version is. I don't know what the latest version is, but it's going to grab the latest. Pull it all down. You can see there's multiple different layers in this. When you're writing a Docker file, each line in that Docker file is one of these layers. So that there's also kind of an art to designing those Docker files, because every time you want to say build a new container, you would need to go and run through all of these things and run through and set up everything. So typically the more volatile, the more something is going to change, you would have that lower in your Docker file.
Right. I guess there's dependencies as well, isn't it? Because if you have you have to install something that something else is dependent on. You have to make sure you get that order of dependencies right for you. Apt install this before apt install Python before you can run Python, things like that.
Right. So one of the things you'll typically see with languages, so for example, Python, is you might pull in all of your dependencies first, just the dependency file. Mm-hmm. And then you'd restore all of those dependencies and then you'd copy over your code. Yeah. And that means as you're changing your code, you don't re-download your dependencies every single time you make a code change. So that's pretty common across languages, whether it's Java or .NET or Python. It can help a lot. There's a bunch of other tricks that you can do to make that a little bit simpler. But you see, you get a bunch of logs. So it worked. You have a thing. And you can even see it's published on port 3000, which you can access. So yeah, if you go and look at a Docker PS in your thing, I think if you Control C this, it's going to stop it. But if you open up a new terminal and do this, you'll see your thing is running. It's on port 3000. It's doing Docker run. You can grab the logs, attach to it, whatever you'd like. So logs should just give you what you had previously.
Same thing.
Another thing that can be helpful is -F with the logs command. That will trigger it to follow.
Oh, nice.
So this will just stay up to date with the output of your container. This is nicer than attach, which is a special Docker command that actually attaches to the process, which if you need IO support, like if you're running bash or something, you need to actually type into that. Attach will help there, but it will also send those sig kills and things like that. So you will actually stop your process if you try to exit this. But since you're just looking at the logs, you can just Control C to stop that, or Command C because you're on a Mac.
Control C. Command C is copy. Control C is to pull out.
Okay. Well, so yeah, that's running. If you could go to your pi.local/port 3000 or :port 3000. Try to get there.
Okay, so this is scales.local. So if I go here and go 3000.
So there's a question in chat. Yeah. How do you detach from a container? Oops. We're both doing too much. How do you detach from a container? Is there any magic? I don't know. I think so. I think you can detach. It might be Control Z, but I don't use attach very much. Typically, when I want to interact with a container, I will exec in and run whatever specific process I'm looking for. Exec lets you run commands inside of the container environment. So if you want to start a bash prompt and just kind of navigate with bash inside of your container, you can use that. That's typically how I've used it. I haven't used attach too frequently. So, cool.
Okay.
All right.
So we've done this, but it don't work.
Yes. So containers isolate things from your host OS. That includes file systems, so you can't access your host file system. It also includes your network. Again, we mentioned how ports wouldn't conflict. So if you run another version of Grafana, it will work, even though they'll both be on port 3000. So
Okay.
that's the issue you're going to run into. To get around that, you want to pass in a -p command to map a port from the internal container network onto your host network. The default networking thing with containers is bridge networking, which is what this is going to do.
Okay, so I guess stop it first, yeah?
Yes.
I'm assuming it's sudo docker stop.
Yep. So that will spin that down. And so it's no longer running. And so you can do run again.
So now docker. Where's my docker run gone?
It's in your other terminal, I believe.
Oh yeah, it's my other one, isn't it? It's in the other one. In the other one. So that's just stopped by now. There we go. Close. So this is docker run, and you say, no, the -p comes first, isn't it?
Yes. So all of your arguments are going to be before the image name, but after the command. So -p, and then on the left hand side, it's going to be the port you want to access it on, and then the port you want to map to. There's a space
like this.
Yep. So -p 3000 will map port 3000 of the container onto 3000 of your Pi. And then we'll all start back up. Important note here, you just created a new container, so you just lost everything. So all the setup has to happen again. This is important because you're going to do this and have to log in. The default login is admin. You'll get prompted to change your password.
But can we just point out it works? It works.
Yeah.
I just did the thing. I didn't do. All I did was just put that port thing in, and now it works. I just refreshed the same thing.
Yeah, this is what blew my mind with containers is suddenly it's so accessible to just access things. If you need a new database, like if you want to play with some sort of SQL like Postgres, or you want to play with MongoDB or something, setting up databases can be really, really difficult. This new password isn't going to matter because it's going to go away. So you can set it to whatever you'd like.
I'll just use whatever's the one that is
cool.
And
yeah.
Cool.
And so now,
magic, as Chris says. Magic.
Yes. So now you're signed in. You can start creating dashboards. You can start setting up data sources, doing all that fun stuff. There's two things that we need to do though to kind of get all of this set up. One we need to do before jumping back into Azure Data Explorer And then the next thing, we can kind of jump into that Azure Data Explorer and start exploring from there, which is as far as I know how to do. So,
Okay.
but
you say though, this is all my account gets lost if I restart the container.
Well, so every time a configuration changes on your container, it's going to go away.
Right.
So this is going to stay. This environment is going to persist as long as you run this container. But if you ever want to change any settings on it whatsoever, if you want to add a new environment variable or something like that, it's going to go away.
Yeah.
So it's best not to treat these things like some sort of treasured item where you just don't want to touch it. If you ever worked on like a mainframe computer where you had like one prod server, and it was very important that prod server never got touched. This is similar. This is sort of how you're running this right now. What we want to get to is something where you don't care.
Yeah.
Where it can all go away and you'll be fine and you can reset it. So.
Okay. So Azure Chris says, I love how confusing Docker port map is. I never seem to get the right side left. Yeah. Always getting around the wrong ways. Which side is which?
So the mapping is always host is on the left side and then the container is on the right side. This works for volumes too. So if you're mapping a volume, the left-hand side is going to be whatever's on your host machine, and the right-hand side is going to be what is on your is inside of your container.
So what I'm gonna do then, I'm gonna kill this. I'm gonna kill this, and I'm gonna do this again. So this is the container side here, yeah? Oh.
Yes.
Oh, where's it rendered? So this is the container side here. This is the 3000. So if I go and change, say, this side to be, say, 80, I could run this, and it would still connect to port 3000. But I just need to make sure that I just use 80 on my Mac here when I'm accessing it. Yeah.
Yes. Yep. That is how that works.
80 to 3000. So I come over here. Well, when that starts up. There we go. So if I go here, I just then just do that because 80 is the default port.
And you'll be, again, everything got wiped out. So new container, new storage system, you have to use admin again and recreate that entire thing. Yeah. So it's going to ask you to change your password, do all that stuff. So we can get around this. Docker includes what's called volumes, which allow you to map things onto your stuff. Right. So you can map something that is inside of your container onto your host machine. And that, in this case, should be enough for us to persist this. As long as we don't lose the Pi, it should stick around.
Okay.
So that's what we're going to look at next. I don't know the best place to store this on the Pi, but we need to map something to var lib Grafana and make a volume to that.
Okay, so if I cancel out this for now, and then I go into my user folder. So if I just create a folder called Grafana. This is probably not the right way to do this, but I'm going to do this. Oh, so Azure Chris says, oh, you can't on Mac OS? I thought port 80 was protected. No, so this is on the Pi. So it's running on the Pi. It's on port 80. Yeah, on the Pi. So it's port 80 on the Pi that I can then view from Mac OS. Yeah. But Azure Chris says /opt is the best place. I promise. Okay. What is /opt? Why do I feel like I'm being trolled here?
I believe those go away. I am not super familiar with in-depth Linuxy stuff. Not my area of expertise, unfortunately. But
opt is the installation of add-on application software packages.
Oh, okay. So what we need to do to kind of come back to this is there is a folder created by Grafana that stores a database. It stores a MySQL or a SQLite database that has your dashboards and your users and things like that. It also has plugins, so you can just install plugins this way. We're going to map that to a file or a directory on your Pi. And then as long as you keep referencing that same volume when you recreate new images, you're going to be pulling that database back in because it's going to be mapping one-to-one that file system. So that's what we're going to do next.
So I wouldn't do this in the real world. I wouldn't just map it to a folder on a computer because this is the cloud. Computers go away and get replaced by new computers. So would I just map this to a file share?
It depends on the environment you're working in. There are on Azure, there's a storage solution, so you can actually have persistent storage. There's also a stateful something in Kubernetes. I forget the exact term. But there's a way to create stateful sets in Kubernetes. Typically, this can get kind of weird because sometimes even though it's supported, storing state can get complicated. So this gives you some ways to do that. For us, since we're running this on the Pi, should be fine. It could lead to issues like if we lose this SD card, we lose our dashboards. So we'll probably want to export our dashboards, for example, which we can do. So if you go back to your run command, we can set this up. So it actually all just gets set up. To do that, it's -V. And then on the left-hand side, on your local machine, where you want that to be mapped to. So some directory you want this to map to.
So I put everything in. So if I go into, this is the directory I sort of do it in. So if I just do that, /home/pi/Grafana. That's what I picked.
Right. And so you can paste that in and then colon, and then the internal directory that you want to map to. Grafana stores this in /var/lib/Grafana.
That, yeah?
Yep.
Okay, so that says every time the container runs, this direction inside the container should be stored here.
Right. And so if you look at that directory, it should be empty right now. But if you go back there in just a second, it should have things.
I now then do the... Why did I do this? I did not want to do that. I wanted to do this one here. So if I now run this, you're saying?
Yep.
And then...
permission denied. Oh, no.
Make sure cannot create directory via lib/Grafana plugins.
Do you have permission to your new directory you just created?
Ooh. I mean, I do, but whether Sudo does. Do I need to? I could do. So Chris is saying /opt is the place to go. So if I go to /opt, then I could do sudo make dir Grafana. Looks like permissions are the same, but it's owned by root. So maybe if I do that and then go here.
Well, so I think this is a good point in the chat. I don't think Docker is run as root. I think it's run as some other user.
That's run as a Docker user.
Make it owned by you, Docker. I don't know how to do this.
So how do I set permissions on the folder to someone else? It's run as Docker. Okay.
Yeah. So that is user and group, by the way. Just so, yeah.
Right. So how do I set permissions? Can I just do...
sudo bang bang is a really handy trick. If you've never used that before.
Sudo bang bang?
Yeah. Exclamation mark. It runs the exclamation mark is the last command you ran. So if you get permission denied, you can do that, and it will just copy the last command with sudo in front of it.
Okay.
Handy little.
So if I do 777, that's kind of give it all the permissions. Oh, you know what? Chris has got the correct thing I should do, which is sudo ch own pi :docker and then there you go. That's now owned by Docker. That's the right thing to do. Let's do it the right way. There we go. Now that's working.
Cool. Yeah. All right. Cool.
So it always helps if there's an expert on the chat who knows how to do this kind of thing. So thank you very much.
Yes. Very, very helpful. So now if you go and look in that directory, you should see a database.
There we go.
So Grafana.db is your database. That's going to have all your fun stuff in it. If you go into plugins, there shouldn't be anything there yet. That's one more thing we're going to add, but it should all get set up. So now you can go and actually log in, change your password, and this time it will stay.
Before I do that, we do have a small problem. We'll be getting an invoice very soon from Chris for his technical support.
We appreciate it.
Okay, so now if I go here, if I go back to here, and then this runs, and I log in as admin, now create a new password. Ooh.
You have that one you saved, so you could use that, I suppose.
It doesn't, it's not, it's, I don't manage passwords. No, it's not doing it. Okay, so how about this one? AKRIZS is awesome. AKRIZS is awesome. There we go.
Nice. Okay,
Cool.
so we've signed in, and we can actually start adding data sources. So the way Grafana works is you set up data sources that are your sources of data. These are how do you access different parts of data. So it looks like it has that add your first data source thing, or you can click that gear and get started. So these are all the built-in ones. You'll notice our Azure Data Explorer isn't there. We do have Azure Monitor. So Azure Monitor is built in. That's going to allow you to monitor like resources and things like that. This gives you a way to grab different data sources.
Okay. So how do we get Azure Data Monitor in here?
We are going to add a plugin. So there's actually, I believe that's mentioned inside this article that we have.
Here we go. The Azure Data Explorer plugin for Grafana.
Yes. So this is an open source plugin that you can just go and explore and grab, and it will get installed for you.
And it's in Grafana as well. So it's, if you see, we're at grafana.com.
Yes.
So does that mean if I go here, find more data source plugins on grafana.com?
Yes. Yeah, you should be able to find it here.
Here it's Azure Data Explorer data source.
So what this is going to do is try to get you to, if you have Grafana Cloud installed, for example, if you created a Grafana thing through the Azure portal, that will set you up for Grafana Cloud, which you'd be able to use to install these things automatically.
So that's hosted on Grafana rather than hosted on my Pi.
Yes, or hosted in Azure and kind of managed, it gives you a more managed thing. So what we can do, there's actually a argument here. If you look, it's actually mentioned in this thing under Docker. You can add this environment variable. This is a common thing in Docker containers to add environment variables that describe certain unique configuration about the environment. This will pull that data thing in. So if you add this to your image, it's going to go and recreate your container for you. So you will lose this container, but we created a volume. So your user will stick around.
Okay. So if I drop that in there like that. That's now running.
Yes.
So if I go back here, here we go. If I should just refresh this. I'm still logged in because it's still got my same user, doesn't it?
And then if you scroll all the way down, it should be there. There you go.
There you go. So
you just click that. It's going to walk you through how to set this all up. So we need an Azure Active Directory user that can connect here. And then we'll be good, I think. Okay. I haven't done this before, so I don't actually know.
I have not done this either. So
cool.
Luckily, that's
why we're here.
Coincidentally, Sam and I were on a chat with a friend of mine, Christos, who's a PM on our identity team, literally on Thursday, Thursday. On Thursday, and we were setting up AAD for something else. So I now know a little bit more about AAD than I did, this time last week. So thanks, Christos, for helping with this. So should we do this? Let's create an AAD application.
Yeah.
So let's go in here. And then, so AAD, Azure Active Directory, it's all about permission management. You have applications that have permissions, and anybody from the tenants can access things or something like that. I'm not an identity expert, but somewhere here, there should be Azure Active Directory. Here we go. So go in here, and then we go to app registrations. We register a new application. So if I do a new registration, you can call this IoT, and then accounts in this organizational directory only. So, or personal Microsoft accounts. So we could actually open it up to, I can open it up to just people inside this directory. So just me, because it's just my Azure subscription, or I could add other directories, or I could have personal Microsoft accounts. So I guess if this was a service that was for public use, but I wanted people to register for it, I'll set it to personal Microsoft accounts.
Yeah, I think we just need a service principal, I think, to access this. So I'm not entirely sure. The documents walk you through, say, to create a service principal, and then use the tenant ID and things like that in order to configure Grafana.
Okay, so if we create the application, where are we here? Register that. Because that gives us the app registration. And a service. Now to create a service principal. What on earth is a service principal?
A service principal is a user that you would use to programmatically access these things. Let's see. This actually walks you through that. There's a whole create a service principal step inside the docs that we're using.
Inside. Here we go.
Yeah. So if you scroll down, we're configuring the data source, create a service principal.
Right.
And this will walk you through how to do that in the Azure portal. And I think it has a Azure CLI option as well.
Right. To create a service principal, follow this instruction in the Azure portal documentation. Create an application and service principal. Okay. Right. So register an application. Set new registration, which we've done. Okay. And that's done. So a service principal is created when you create the Azure AD application.
Oh, well, that's handy.
Nice. Okay. So we've done that part.
Cool. Next step is adding service principal to the viewers roles. If you scroll further down in that doc, there's a next step so that we can actually view the data that we're trying to actually access. Right. So we need to give the service principal access to read our Azure Event Manager. That's Data Explorer. There we go.
Okay, so this is. So if we go to here, we've got that set. If we then go to our Data Explorer, access control. Is it access control? Yeah, access control. Add role assignment. So add role assignment. Okay. It said here we need to assign reader to the cluster. So you want the reader role. So it's reader role. The next user group or service principal. Or is it? No, do we want to manage identity, don't we?
What does it say?
Okay, right, set reader is what we did. Role, reader, next. Yeah, it's a service principal, isn't it?
Yes. Sorry. I think so. It sends you to the Azure Data Explorer, and then it has you select your sample data that we have.
Sorry?
I'm just looking at the doc that we have. If you scroll down, because that's just having you copy the subscription ID, which you should already have from creating the account. But down here it talks about permissions. So this sends you to Azure Data Explorer to grab that.
But it says in the sign the application to role thing here. Oh, is that, do we need to set that at a subscription level?
I'm not sure.
Because this is not setting a role on the subscription. Unless we do it from, maybe we need to do it from the application. Registrations. Let's create one. How do I assign app roles? I don't know.
I don't either. This is not something that we've done before, so we actually don't know.
We don't know. Because this is unless it's mentioned. So if we go to here, we go access control, add. Was it add role assignment? Did it say? Yeah, add role assignment. So add role assignment. Reader is the role. The members that we need is service principal.
Well, I think you need to add your service principal, right?
So if I search for IoT, we've got two service principals called IoT now.
Oh.
Okay, it's got two apps there. So if I then go, let's have a look at my app registration. Do I have two apps called IoT? App registrations. No, just one. 4B33. That's the one we created.
Yeah, so I think you want to copy that one and then paste that into the search, and it should
copy that client ID. So if I go here, bin those, select members. Nope. Because yeah, if I search for IoT,
you get two.
Yeah, if I add those, okay, the object ID is BEA and DAE. That object ID is 137.
Huh. I'm not entirely sure. It seems to match what is shown, but I'm not entirely sure if we're doing it right. If not, we can figure it out.
Because they added two role assignments. Oh, there we go. Data Explorer cluster reader.
Got it. Okay.
So that's the Data Explorer cluster that we've added. Okay. And this, once you click on that, doesn't give me anything useful. Let's try clicking on it from here. Okay, so this is our app. So one's the app and one's the Data Explorer cluster.
Right. Yeah, I think we're just using IoT as names for everything. Yeah. And that might be leading to the confusion.
Yeah, we probably should have different names things, shouldn't we?
Yeah, maybe like what the actual thing is.
Yeah. So Chris says there's a reason why there are IAM pros. Yeah.
Yeah.
Yep.
Yeah.
Yes. Name the same thing is kind of confusing. Yes, we are learning this as we go along. Should not have named it the same thing. Okay, so we're getting somewhere. We're getting somewhere. So in the get values signing section, copy 3 property values: directory ID, application ID, and password. What's the get values for signing in? So this is from the app. Okay, so go to the app. That's not the cluster, we're on the actual app itself. Go to the app registrations, IoT. And that is example app overview. Huh. According to this, directory ID, application ID, and password should be there. That's a directory ID, application ID, and we can get password application secrets. So directory ID, there we go, directory ID, application ID, and then we need to create a password.
Okay. And that will let us access things.
Okay. So if I go certificates and secrets, new client secret, description of this client secret, no. Find a password, clients, whatever. Now I'm going to copy this because I could imagine this is one of those annoying secrets that's not going to be
easy to find again.
Yeah, probably never be able to find them again. So I'm going to just create just a blank doc here. I'll hide it by calling it stuff. Put our password in it. Don't do this at home, boys and girls.
So the nice thing that you can do with Grafana is you can reconfigure your data sources whenever. So if you did lose this, you could get it back.
There we go. Got that body directory and password. If you dot stuff it, then it's super hidden. Yes, that's true. I should call it dot stuff, shouldn't I, rather than stuff? There you go. Yeah, that's secret. You know,
very secret.
Base 64 encrypted as well while I'm at it. Yeah. So we've done that.
So we have all that. I think the next thing it has is some management command. I'm not entirely sure what this does though.
Oh, this is just creating the thingy. So got read of the Azure Data Explorer cluster. Now we had added it to viewers role in Azure Data Explorer database. So Azure Data, I've got too many tabs open. Let's close some of these down. Right, so if I go to the Azure Data Explorer database, we needed to, it's on the database, we need to permissions. Right, so we go on the database itself, permissions, add, viewer. We don't know which one it is. Let's add both. So that should give both them viewing access to the database itself. There we go.
Okay. And then, cool.
Select save. There is no save. I guess it saves automatically now.
And then they have, yeah, I don't know what this management query is.
No.
Let's see, what is it doing?
Test. Okay, so database is weights. Add viewers, application ID and tenant ID. Okay, so if we put the application ID in here, so this is saying that anybody who's from this application app, this app is a viewer on the database. Could not pass that, sorry. Database. Entry weights of kind database is not found. Oh, it's a table. That's the table. The database is 80 scales. No.
That's new. That's
Huh. Oh, that's at the cluster level, not the database level. I can try at the cluster level. No, I can't do it at the cluster. This database is. There we go. Query. Same blooming thing, isn't it?
looks like it. I'm not. Yeah. So we aren't familiar with Custo. It's not something we've used a lot, so we're figuring out the syntax a little bit.
That's got it in a wobbly braces and the thingy. No idea. Okay. I mean, we are basically at time, but I'm not sure whether we're going to get this through or not.
We could do this next week.
I think,
I'm just trying to. Yeah, this just uses the database name directly.
And it's not liking it. That's the database name here.
But add database.
Because that's what it's got. It's .add database viewers. I don't know. I think we're going to take this offline and have a play with it, and then maybe what I might do is delete some of this and recreate it with sensible names.
That might be handy. Could be a good excuse for us to kind of inject some bicep or arm stuff.
Yeah,
we can take a look at this offline. I'm not sure it makes a lot of sense for us to bash our head against this wall live.
Just to prove this is live and we don't know what we're doing, we're working it out as we go along. So.
Right, we are building this app live. So we are architecting it and designing it and making these decisions relatively unscripted and live. So we don't necessarily know how this is going to go. We can fix this up though, and then build our first dashboard next week, and then get everything sorted out, because that'll be super fun. Then we get to look at how to make decisions from that dashboard. So
nice. That's pretty fun. Yeah, next week.
Yeah.
I'm just going to quickly hop on. Thank you both so much, and thank you everyone for joining on today. I do have one thing to share. We'd love to hear your feedback. Please visit this link. The event code is 15300. We'd love to hear from you. Thank you.
Cool, yep. Thank you, everyone.
Bye.
Thanks.